This is 21m.383 Computational Music Theory and Analysis, and this is a lecture on the concept of voice leading and how we can detect it computationally. That was given on the Thursday before we all split up for COVID. Let's start with some Bach. This is the chorale from his Cantata 26. That's a gorgeous piece of music. But here's one of the weird things about it. If you were to turn this in, depending on who your harmony teacher is, you might not get 100%. Because Bach has something in here that a lot of harmony teachers would call an error. There is a parallel fifth in here. If you want, go ahead and rewind the video and see if you can hear it. Otherwise, we'll make it a little bit more obvious in the next step. Okay, here's just the opening phrase. Were you able to hear it? If not, let's make it a little bit easier, and I'll just highlight the two parts that have the parallel fifths. Which measure is it in? The answer is measure 4. Let's listen just to measure 4. So Bach has done something really interesting here. By the way, some of your teachers will say that this is an acceptable case of parallel fifths because Bach allows himself to do it when there's an anticipation just before a fermata. I just want to throw that out there in case you've heard this and you're wondering, your professor's stupid and doesn't realize this. But what I want us to do is think about what are all the cases where Bach does use parallel fifths or does use parallel octaves. In order to do this, it's going to take too long to do it by hand. So we're going to write computer programs that can identify all these cases. And what's great about it is once we're done writing the computer program, we can find it not just in Bach, but in Beethoven or in pop music or anything we want. The same algorithms are going to work. In order to do this, first, let's make sure that we all have a handle on what the different types of motion are and what do we mean by parallel fifths. So let's start by identifying several types of motion. I think the first type of motion that's most important in counterpoint is contrary motion. That is to say, where you have two voices that move in opposite directions. Notice that when we're talking about types of motions, we're always talking about 4 notes, 2 in one voice and 2 in another. Now let's look at a second type of motion. What do we call this? This is what we call parallel motion, which is a special case of something that we'll call similar motion. Here we have parallel fifths. One other type of motion that I'm not going to illustrate here, and that's called oblique motion, where one part moves and the other part stays the same. So go ahead and fire up Jupyter Notebook and let's program a system that can identify parallel fifths when they arrive. Okay, so we'll create something called Voiceleading, and we're going to unlock some Music 21 things for you to do. We can import note, pitch, stream, corpus, and the brand new module that you've unlocked, interval, which will be great here. Let's start. Go ahead and create 4 pitches, and I'll call them P1, V1 for the first pitch in voice 1, which I'll make the lower voice of 2. P2, V1, the second pitch, and the first pitch of the upper voice, and the second pitch of the upper voice. And what I'd like you to do is go ahead and choose notes in here that create parallel fifths for you. I'll pause the video for a second while you do that. Great. The pitches that I chose were C4, D flat 4, G4, and A flat 4. Now what you could do right now is we could create the interval between C4 and D flat 4 is a half step, and G4 and A flat 4 is a half step or minor second, and between C4 and G4 is a perfect fifth. And we could use all of the interval routines that you've created for previous problem sets, but now since we've unlocked the interval module, we can use the interval object. So I'll create the first vertical interval, and I'll call that vertInt1. It's interval, the interval between the first pitch of the first voice and the first pitch of the second voice. And I can get that vertInterval1 is a parallel fifth, a perfect fifth, sorry. We haven't figured out if it's a parallel fifth yet. So we can do some things with this. We can get its name, or we can get its nice name, or we can get its directed nice name, but we're mostly going to be using name here. If you want to know what's possible with an interval, there's a couple things you could do. You could dir on this. The Python dir command is really great, but you're going to see a whole bunch of things that are just really complex and might not be everything that's applicable to an interval. So one of the things that I like to do is we're going to open up one more module for you. It's called base. And what base is it's just the module that all of these other things, pitch and note, well, not exactly pitch, but note and stream and interval all inherit from. And there's something called a Music 21 object. So we can create just a generic Music 21 object, which represents anything that can be put on a staff. So now we have M21's just, I don't know, something that you can put on a staff. It doesn't represent anything. But what we can do is we can subtract out everything that is present in an interval object from what's just a general thing all Music 21 objects have. And this gives us all the things that are specific to intervals, so we can figure out how many cents there are. Go ahead and look up what a cent is, or I'll just tell you it's 1/100th of a semitone. So major third has 400 cents, and so on. We can see if it's a chromatic step, if it's a skip, and so on. So we can get, for instance, vertInterval1.semitones is 7 semitones, which should be 700 cents, I hope. Good. Okay, so now this is how we can create one vertical interval, and again, that interval is a perfect fifth. Then we can get the second vertical interval between, what is it, P2 V1 and P2 V2. You know, it really doesn't matter if you put voice 1 as the top voice or voice 2 as the top voice. All that's really important is that you're very consistent with it. So now we can see that vertInt2 is also a perfect fifth. What I'd like you to do now is to write a function called isParallelFifth that takes in P1v1, P2v1, P1v2, P2v2, oops, and returns true or false on whether these four pitches form a parallel fifth. In class, we took about 20 minutes to do this, so feel free to pause this video. Okay, here's some of what I saw people doing. We can create those two vertical intervals, interval between P1v1 and P1v2, vert interval 2 equals the interval, I can spell it really, between P2v2 and P2v1 and P2v2. You're going to eventually have some errors when you're doing this because you're going to forget and put the wrong P1, V2, V2, whatever in there. Always double check that part. If you're working with a friend, then go ahead and double check that way. And what some people decided to do was we'll say, hey, if the number of semitones in the first one is 7 and the number of semitones in the second one is also 7, well, then we'll return true, false. And so we can go ahead and try this. Nicely, I can name these the same things. And we get true here. And if we go ahead and do this on, we'll do a different one. For our second one, instead of A flat, we'll say it's a natural 4 and false. Great. Have we solved the problem? Now let's think about some other special cases of parallel fifths. Would we call this parallel fifths? I certainly would not. It's very important that both of the intervals be fifths. What about this issue? We're going to leave the bottom voice on D and D and the top voice on A and A. There's no motion whatsoever. Generally speaking, we do not call that parallel fifths. You're allowed to sit on one note as long as you want. How about this here? We're going to put the bottom part alone, but the top part we're going to take up an octave. There's parallel twelfths. We generally call those also parallel fifths. Go ahead now and go back to your Jupyter notebook and make sure that all of these cases work properly. You're going to be wanting to look within the interval object for something called simple name, which reduces the interval to within one octave. Now that you have your system working really awesomely possible, I want to talk about one last case that comes up sometimes, and that is what happens where you have a fifth at the beginning and a fifth at the end, but you actually have contrary motion and you move from, say, a 12th to a fifth. Do we call this parallel fifths? This is a point of contention. Some people call them anti-parallel fifths. In general, anti-parallel fifths don't have the same perceived problems of parallel fifths. That is to say, we don't start confusing the two voices into going into one, but we, again, tend not to use them in writing tonal harmony, in part because it requires both voices to be very jumpy, and also it just kind of seems a cheap way of avoiding writing parallel fifths. So a lot of systems will check for them, and Music 21 has an is anti-parallel fifth method that you on intervals that you can use. Let's jump back to Jupyter Notebook and see where we left off. Congratulations, you've unlocked another Music 21 module. This is the Voiceleading module, which is going to be very helpful for things like this. So go ahead and import from Music 21 the Voiceleading module. Within the module, there's really just one class that you're going to be wanting to use a lot, and I'll call it VLQ for short. It's the Voiceleading Quartet. It's just a name I come up with. The idea is it's 4 notes that, or 4 pitches. Well, notes, pitches, I'm not exactly sure. You can pass in your actual pitch objects, or you can pass in note objects here, or you can just pass in strings. And this defines 4 notes, that these 2 are linear, so that C4 moves to D4 at the same time that G4 moves to A4. So this is our Voiceleading quartet we'll call VLQ. I want you to think for a second. Is it the first note and that has to be coinciding with the first note of the other voice, or is it the second note of a voice that has to coincide with the second note of the voice, or do all of them have to move at the same time or none in order to have a moment where there might be parallels? So is it the first voice or the second voice? It's actually the second voice that's really important. So the first voices could have come at different times. And if you are confused a little bit on that, go ahead and go back to the original Bach example where you'll see, well, here, actually, why not do it here? Of course, parse BWV 26.6, and we'll go ahead and show that. We can actually see here that the opening part, it's that between the soprano and the tenor, their notes don't start at the same time, but they end at the same time. So here's the soprano note, note 1, and here's the tenor note 1, which moves to note 2 at the same time here. Okay, so it's really, we're talking about the second notes being at the same time. I'm going to go ahead and delete this. That was a little bit of a digression. If this were a super video, maybe I would edit that to be a little bit better, but I'm not going to do it right now because we're excited about the properties of voiceleading quartets. We can again figure out all the things in a voiceleading quartet by removing the things from any general Music 21 object and see that, hey, there's anti-parallel motion. We're probably going to be looking for that. Is it contrary motion? Are there parallel fifths? What are the vertical intervals? And so on. So we can play with this. What are the vertical intervals? Parallel, perfect fifth. And what are the, is this parallel fifth? This is a method. There's no way to know in this if it's a method or not. You just sort of have to try and say, oh, nope, it's a method. So go ahead and try that there. Or you open up the Music 21 User's Guide, and that will tell you everything that you need to know. By the way, if you're on Jupyter Notebook, you can do things like put a big question mark there. Oops, not 2 question marks, 1 question mark. Will give us the documentation and show you how these things work. Diminished fifth to parallel fifths is perfect fifth is not a parallel fifth, and so on. So that can be really helpful. That double question mark, by the way, gives you this a little bit closer to the source code. And we're still, even despite being separate, we're not going to look at source code to solve problems. That will just keep on our honor. We can check to see, is there anti-parallel motion? Hit tab to complete on that, and no, there is not. Okay, so now we have something that lets us look at a place where a voiceleading moment happened. Nope, I got rid of the Bach here, but you can imagine that there are a lot of voiceleading quartets, and any particular one of them might have a parallel fifth. So we're going to go ahead and make our next part, finding all voiceleading quartets in a piece. So we'll go ahead and say that Bach is our new favorite Bach chorale, which is BWV 26, movement 6, and this is a nice one. It has 4 parts in it. Hopefully, yep, good. And so what you're going to want to do is see if you programmatically you can find that parallel fifth in there. This took about 30 minutes in class, so go ahead and take some time to do that. If you want, you can pause the video, or I'm going to give you some helpful hints. Okay, here's helpful hint number 1. Do we want to go through what's the best way to iterate? Are we going to, and this is something you should always be asking yourself, do you want to be using Bach.flat, or do we want to be doing Bach.recurse, or our new favorite from last class, Bach.quartify? Let's go ahead and look at that. It's going to be kind of fun. Sorry, it's a little bit slow today. Maybe it's because it's recording. Yeah, is that going to be useful? Maybe, maybe not, or some combination of all of these. The other term that people thought about a lot was buffer. So if you haven't thought about if you're going to keep a buffer or a cache or something to figure this out. So I'm going to stop the video for a second and you can go ahead and check on this. Okay, here's the next little hint. The answer to what's the best way to iterate is actually going to be a little bit of a combination of the two, because you're going to want, I think, actually there's multiple ways to solve this, but one of the ways that people found to solve is that we would iterate among all of the parts. So we would say that we can do this in range 3, since we know that there's 3 parts. I'm not going to make you do this with a piece where you don't know the number of parts, but you can make that something that you could do later. I'll call this I upper, because we're going to go from the top part to the bottom. And so the P upper, P up is that particular Bach part. And you're going to want to do something where you keep track of a mapping between the position from the beginning of the score to where you currently are and what the note is. And one of the ways that you might do this is iterate through all of the notes flattened. So we're not going to flatten at the highest level, at the score level, but we'll flatten each part. So we'll do this, and we'll say something about the offset of the note equals something here, and then we'll go through for each of the lower parts, and we want to start with the next one. Actually, we only need to go to 2 here, I believe, but no, we need to go to 3, 4, don't we, here, something like that, and do something on P lower, Bach.parts, I lower, lower buffer equals something here for N in P lower notes, lower buffer and at some point we're going to need a voice leading quartet. You might be wanting to keep track of the last note and upper last note and lower last note and so on, but this might give you a little bit more of a hint of where we're going to go. Go ahead and pause the video. and work on it for a little bit more, then I'll give a little bit more hints on where we can be going. Okay, so one of the things I want to do, this is not the most efficient way of programming. You're going to find that we're going to be doing things twice here, but twice is not always enough to want to want to extract into a separate routine. If we're doing it 4 times or 5 times, maybe definitely would. But we'll keep track of, up here when we're iterating through the upper part, we'll keep track of the last note here. And what we'll do is we want to say if the last note is not none, that is to say if we're not on the first note, we'll store the buffer here. We'll store the last note, the previous note, we could call it, and the current note. So we're going to say at offset, well, at offset 0, there's nothing. But in this particular piece, at offset 1, here there is going to be A4 to B4. At offset 2, there's going to be B4 to C5. At offset 3, there's going to be C5 to C5, and so on for every note in the top part. And then the part I always forget to do, we'll set last n to the current n. Otherwise, we'll do nothing. Then we do the same thing for the lower part, except we won't really even need to do this. We can say our lower buffer is last n to n, but maybe we don't even need to do this. So what we can do is, in fact, we don't even need the lower buffer. I'm going to put this out. Well, the only thing we do need is last, we'll call it last lower n equals none. And we'll say if last lower n is not none, we can put this in here, and then here. Actually, we'll check if the lower note's offset is in the upper buffer, that is to say, then we have a voice leading moment. Yay, that's great. So the upper last note and the upper current note is, we can unpack the toplet from the upper buffer at that particular offset. Go ahead and pause this video right now if you don't understand how toplet unpacking works. That's the Google term, toplet unpacking, and that might help a little bit. Otherwise, this will be a little bit confusing. Great, so now we're iterating through the lower part, and we're at a particular offset, and n is the note after that offset in the lower part, and the other n's are all the notes around it. So we have a voice leading moment. So we can do, we can create a voice leading quartet at this moment from the last lower, it's going to be too big if I don't do this, from the last lower n to the current n to the upper last n to the upper n. Good, so now we have a voice leading quartet, and if that voice leading quartet is a parallel fifth, we can do something. Probably we return it to do something like this, but in this case we'll just print, yay, P5, parallel 5 found, and then maybe, oh, I don't know, we can say offset is n.offset. Great, and the last thing that as I said, I'm going to forget to do, last lower n equals n at this point. Great. So, and maybe we'll put some debugging things in because we're just writing fast. This is not code that we're going to turn in, but maybe we'll say at this point that we're going to print upper part is I, and we'll put here lower part is I lower, That'll give us some sense of what's happening. And let's see if that works. Oops. Is I upper? Sorry about that. Lower upper part is 0. Lower part, that's soprano. Lower part is alto. Nope. Lower soprano to tenor. Yep, parallel fifths found at offset 13.5. Lower part is 3. Bass, nothing there. Now between alto and tenor, alto and bass, nothing. Between tenor and bass, nothing. We can double check, are these things symmetric? Think in our head. Yeah, they're symmetric, so we don't need to look at the other parts. So there's exactly one parallel fifth in here. Great, so now we've been successful at finding all of the voice leading quartets within a single piece. And we've been able to look at each of them and consider whether they are parallel fifth or whether they're contrary motion, similar motion. Think for a second, what are some of the questions that you could ask? Does Bach use more contrary motion, more similar motion? What are the voices that move in contrary motion more often than other voices? Is parallel motion very common as long as it's not in parallel fifths or parallel octaves? There's a million questions you could ask by looking at all the voice leading moments within a particular corpus of pieces. And we're going to talk a lot more as the semester goes on about corpus studies. With one piece, you might as well do it by hand. But with 100 pieces or 1,000 pieces, let's let the computer do it. And especially if we want to compare a corpus that we might know very well with one that's a little bit different that our friend knows. And we can, a lot of times corpus studies ends up being kind of a paired or a collaborative publication setup because I know a lot about 14th century music. I might have a friend who knows a lot about 17th century music, and we might see how are our corpora different when it comes to voice leading. But for now, let's end by getting back to the Bach chorales. There's a particular thing called the chorale iterator, as we've used in the past, and we can use this to go through all of the Bach chorales and figure out where all the parallel fifths or parallel octaves are. And that would be a fun task for you, and I encourage you to do that now, but I've gone ahead and done them already. So at some point, I don't know, maybe about 10 years ago, I went through and looked at all of the cases I could find and wrote a program that would also label exactly where they are. So here's the one that we were looking at. We have parallel fifths with the tenor, and this is a case that we call an anticipation tone. One of the things that I wasn't taught, but that's very common, is that Bach is willing to have parallel octaves, here's a D and a D against a D and a D, and parallel fifths if it's at a fermata. So the fermata kind of resets all expectations, and that's been kind of an interesting thing, not something I was taught. I was not taught this particular case that's low. Oh, well, this is basically the exact same thing in the repetition. E and B moving to F and C. And that's caused, interestingly, by this neighbor tone that now the soprano parts Bach didn't write himself, general, but this is something that would be easily removable. You don't really need that neighbor tone, but that allows there to be parallel fifths in here. And you can see that there's quite a number of things that are fermatas. We have passing tones. That was something I was never taught. This is a piece that also has a violin part. Let's find where that passing tone was. Here it is. Parallel fifth between the alto and the tenor caused by this particular passing tone in here. So it's good to create your own repository of pieces like this. That way, the next time somebody tells you that your own music that you're turning in for harmony class is out of style, or somebody says, Bach would never have done that, you can say, oh yes, he did. Thanks for a great class. We'll see you again on Tuesday.